Hello and welcome. And I think there's something weird with the YouTube stream because it's not showing up on my channel, which is very unusual. Okay, like the weird thing is it seems to be up, but for whatever reason it doesn't show up. Okay, that's I don't get it. Okay, anyway, I will not spend time on troubleshooting this because this is just nuts. Yeah, I mean the stream is up, it just doesn't show up on my channel for some strange reason. Okay, then I will just quickly do... Where the heck is my notepad? Oh, it's stuck again. Okay. I'm getting the feeling that this will be one of those weeks where things are just going sideways all the time. But let's see. What the heck? It doesn't show up. Yeah, here it is. Yeah. Okay. So just a second, I just need to quickly post this on Reddit, and then I will start with the actual coding. And this weekend the goal is to actually try to do some compile stuff magic. I'm honestly not sure if it will work. We will see. But you know, that's part of the fun, trying to figure out things and seeing if they work. Okay. Let me just double check if by chance... No, still doesn't show up on my channel. So curious that this happens. Anyway, YouTube is weird. Right, so last time I managed to finish my big refactoring. So now we have changed around a lot of things, all the tests are passing, and the load test actually runs faster than it did before, which is great. And we also solved like one more puzzle out of all the puzzles. I actually forgot to rerun the entire benchmark. I will need to do that at some point. But yeah, I mean, things are looking pretty good as far as that goes. And as you can see, I also have some const explorer tests already. And this was actually in preparation for the work I want to do today. So the thing about killer Sudokus is that one of the kind of core solving mechanics is that you need to think about what are the possible sets of numbers that add up to a particular sum, right? So let me just quickly go to a killer Sudoku example. So if I just go daily killer Sudoku, right? So sure, let's just pick this one for example. Like if I have a 7 here, like the only option how to make a 7 in 3 squares is the numbers 1, 2 and 4. So you already know immediately that, oops, not 3, 4. You already know that this has to be the case. Like there needs to be numbers 1 to 4 in these 3 cells. And of course that already immediately, you know, gives you extra information for all the other, you know, squares in the puzzle. But this is kind of one of the very core solving techniques. So this is something I want to implement, but I want to implement it in compile time. So basically have a table that gets automatically computed for a given size of a puzzle. So right now we are still working only with 9 by 9, but you know, all of the stuff I'm writing should be just generic enough so it works for any sizes. That's always my goal. So basically have a table of these sums, and the minimum sum is 3 because, you know, like if I have a 1 and a 2, that adds up to 3, so that's like the minimum you can have. Because again, within like each of the killer blocks, these numbers need to be unique. So at minimum you can have 1 and 2, and because all of the numbers need to be unique, at maximum you can have 1 to 9, which adds up to 45. So that's the kind of the range you can have, and it's all about figuring out, you know, what are all the different combinations, how you can get to that sum. So let's just start writing ideas down. Okay. So I want to have a table of sums. So this will be a sum going into the list of possible sets of numbers. And this could be a map, but honestly, considering that the sums just go 3 up to 45, I might as well just make it an array and, you know, index it, you know, starting at 3, just do like index remapping. So basically this will be an array that goes from 0 to 42. And within this array, so this would be like array of, and I said the internal thing needs to be a list of possible sets. So this, again, list means array, so this would be array, and then a possible set. Well, that was the thing I worked on in the big refactoring, is creating the bit set. So this would be a bit set. So this is kind of the structure I'm looking for. So a double array of bit sets, where each of the bit sets represents like one set of numbers that adds up to a particular sum. And again, this thing I want to just generate at compile time. Now, of course, there are a couple of issues here. The first issue is that array is compile time sized, and that already creates a kind of a problem because I cannot really have an array of like different sized arrays, right? It's a thing I can work around by just making it a square, well, not a square, like making all these arrays the same size, basically based on the maximum size, which would be a little bit wasteful, but it's possible. But I kind of also want to think about like other possibilities. I mean, one thing I could do always is just have this flat and basically have a second array next to it, which would basically tell me the offset and the length. Because, and this would just be like a flat array, right? This would work because then, like, let's say you know, okay, let's just go for some example, right? So one option is this, second option is something like this. And then basically if I want to access, like, you know, the second element for sum 12, for example, I would go into the hello. Oh, let me just quickly switch to the it's you. Hey, welcome back. Right, so if I want to access the second element for sum 12, for example, I would first go into the offsets for the element 12, and that would give me the offset and length, right? And then I basically know that I need to do data offset plus 2, and I need to ensure, you know, that 2 is less than, well, sorry, actually second would be 1, obviously, because we index from 0. But basically I need to make sure that 2 is less than equal length, right? But then I just access data at the offset that I have gotten from the offset array and plus 1. So that way I kind of get around different lengths. I kind of like this because I need to kind of do double access to access anything, because I first need to figure out the offset every time, right? But that's not a big deal. And especially like all of this is, you know, compile time data, so this will all be just constants. So for those it really shouldn't matter that I have a double access, because they should all get just like smooshed together into like one thing optimized out basically. Okay, so let's get rid of this. I really like this idea. But okay, so now we have the following problems. So at compile time we need to figure out, we need the total number of elements in the array. Okay, so this is a bit tricky. So this will be combinatorial numbers that I need to basically compute and sum together. I mean, they're definitely, it's all just constants, so it's not like we cannot do this. Like, we definitely can do this. It just won't be absolutely trivial. Like, it will be a bit tricky. Then I need a const expr function that generates all the different sets that sum up to a number, right? Right. And actually, I'm starting to think I maybe have my dimensions in the wrong order. So, because what I can easily do, I can for okay. So what I can definitely do with the bit sets already is I can just generate sets with the same number of bits that have different properties, right? So I can relatively easily generate all sets with x numbers that sum up to n, right? But I cannot. Oh, it's almost like I'm missing an extra dimension somewhere here. Because it's not just the sum. It's actually number of squares to sum to a list of possible sets of numbers. Yes. So this won't be 3 to 45. This will be... Huh. Okay, this will be trickier because... I mean, clearly, so if I have two squares, right? Like the maximum sum at that point isn't 45, obviously. The maximum is 17, which is 9 plus 8. And the minimum is still 1 plus 2. So... yeah, it definitely needs to be number of squares into the sum. Which still works with this idea of the offsets and length. It's just that this actually needs to be it will not be enough to just have a simple array. Because that would be good enough for like one dimension, right? Like I could jump to the start of the 3 square sums, right? But then I also need to figure out where the list of the sets starts for specific sum. But if I make this two-dimensional, okay, then I kind of have the same problem I had before, because again, like different number of squares sums up to different range of sums. Okay, this is tricky. Like these two things are just like these two things are almost like one thing together. Yeah, and also like number of squares and a sum. Like it will not change based on the size of the puzzle. What will change is the range of these two things. Or I guess the range of the number of squares, actually. No, but also the sum, because we have a like higher maximum value we can have in a square. Right. Okay. Yeah, because for like a 16 by 16 puzzle, we can basically get like a 15 plus 14, right? Well, actually 16 by plus 15, yes. Okay, so how... Like, this is... All of this is almost a map, but the problem is, like, at compile time you kind of need to simulate maps using arrays. There isn't really great way to do it like directly. I mean, this part I can definitely do. I'm very confident that I can just generate all sets with X numbers that sum up to N. So that's the thing I can write, but this part is the tricky part. Like, how do I actually represent these two dimensions? Because of course the issue here is that this thing, this will have different lengths for the different combinations of the for the X and N, right? Oh, sorry, I'm kind of hiding it with my head. Which is where the offset and length comes in, because this is, yeah. But how would I do the offset and length? It's almost, I kind of want to have a steady pair of two ints, like a map from a pair to a pair, right? So for like from I mean, you know, like, ask questions if you are yeah, I mean, I'm sure I'm scaring people off. That's definitely the case. Yeah. Okay, so I kind of want to map the number of squares and the sum into an offset and length. Can I do that? I mean, again, I can do it by just having a grid. Because, like, I know what's the range of the sum, and even though, like, let's say for the number of squares too, right, like the range again would be 3 to 17, of the sums, but I know that the total range is 3 to 45. So there would just be a bunch of elements that are not filled in, but it's okay. So basically this would be like 9 times 42 grid. So the 9 would be corresponding to the 9 different number of squares. Actually 8, right? Because it doesn't really make sense to do it for like 1 square. So I can start at 2 squares basically, and go from 2 squares to 9 squares. And then the range is 42 because that's the, or I guess 43, right? Because that's the number of unique sums. Amazing, as I was off by 1 on both dimensions, like I was +1 here and -1 here. And yeah, so I can have this kind of grid of the offsets of std per offset length, right? Something like this. And then just have the data next to it. I still need, right. Yeah, I still need this thing, the total number of elements in the array, which I know the number of elements for this grid, which is 8 by 43, but for this part I would have to loop okay, so if I have function that returns the number of unique sums made with x numbers and not sums, sets, right? Function, so basically I have a function that generates the sets with x numbers and that sum up to n, but also need a function that just returns the number of those. Yeah, okay. X numbers and summing up to n, right. So if I have these two things, then I can basically just loop around, like have a simple function that just loops around, figures out the total number of elements of this array. Okay, no, I think I have some idea how to make this work. So let's start some coding then. I will just start like doing this on the side. So let's just create a new file over here. So let's just do, don't add this into anything. Let's just call it context per experiment, right? And this will be a completely separate things. So let's just create a new executable for this. Context per experiment, yes. Context per experiment, and I don't really want to link it against anything. and then here, yep, just switch it over, perfect. Okay. Just create a very simple main, returning a 0, and then std cout. Oops, easy. Yeah, okay, since this is main, I can actually afford to use std. Just to see if this is working. Okay, build it, run it, print it out hello. Okay, cool. So again, I want two functions to start with. One to count the number of unique sets, and second one to generate the sets. And I'm kind of thinking that honestly, well, I was kind of thinking that there might not be an easier way to count the number of unique sets by just, instead of just generating them. But that might not be the case. There might be there might be a formula to do that. It would be a bit tricky though. I mean, it's not just like a simple pick n elements out of a bag, right? Because of the sum requirement, this gets a bit tricky. I mean, it is definitely a recursive formula though. Because, okay, so let's think about it, right? So let's say we are trying to figure out how many unique sets of four numbers, let's say. This is just as an example, right? So how many unique sets of four numbers in the range of 1 to 9, right? Because that's our Sudoku. Sum up to like a specific number, and let's just make up a number. Let's just make up 21, right? Well, you can also think about it that this basically is how many unique sets of three numbers, 1 to, well, not 1 to 9 now. Right, okay, slightly differently. I mean, it's being recorded, so, you know, if someone watches it, you know, the thing is, I'm trying to figure out if I can come up with a recursive formula. It's not... So the thing is, this thing kind of boils down to, okay, like if I, for the first number, pick a 1, right? If I pick a 1, then I'm looking for three numbers, 2 to 9, that sum up to 20. If I pick a 2, then three numbers, you know, 1 and then 3 to 9 that sum up to 19, and so on. So basically for a specific number, so I can kind of build it up from from the bottom up, right? Because I know that if I want a set of one number, right, there's only one way to do it. And then adding on top of that two numbers, well, okay, it's not, damn it, it's almost there. Like, I cannot exactly make a formula out of this. It needs to be an algorithm. But the good thing is it builds up, right? But unfortunately it builds up not in a not very clean way, because I need to keep track of the numbers I can still use, kind of. Yeah, so probably actually the easiest way just to count the unique sets is just to generate them. Like, that really might be the cleanest way to do this. Because if I have in parallel this kind of complicated logic on the side, I mean, it would work, but honestly, like, this, I'm starting to doubt that this would actually be faster than just like looping through the sets, because that I can do pretty easily. So okay, let's just try to play with that. So let's just grab the bit set. So let's just link the bit set to into my library, into my binary, I mean. So target link libraries. This thing should be linked against core, against project options, project warnings. Come on. Okay. Right. Not main. This thing cost extra. Okay. So let's just have a const expr unsigned number of sets function, right? That takes the number of squares and the sum, and I cannot spell again. Okay. Sure, whatever. Okay. So I will start with a bit set. So this will be const expr bit set. And the bit set I start with is and this is Sudoku bit set, right? Just quickly check that. Yes. So the method that I want is this one. So the maximum, okay, so I also need the range, so unsigned max. So max and number of bits will be num squares. And now what I want to do is just to loop around. So while okay, so these are actually the iterators from last time. So for auto and this was Sudoku bit set sets. Oh right, actually I don't need this thing at all. Okay. Bit set sets maximum and then num squares, right. And then here I need a second loop, looping over the bits, bit set bits, and this takes bit set, right. So this will be this one, and right, what I want to do here, unsigned result is 0, return result. Unsigned sum. So we sum it up, and if it's the sum we are looking for, then we increase the result. So this will be, B will be just a specific bit. Okay, so that's directly what I want. So tmp sum plus equals B, and then over here if tmp sum is the same as sum, then result plus plus. Okay. So I think this should actually satisfy the const explorer requirements, and we can test that pretty easily. So what I can do, I can just well, okay, static assert, right? So number of sets with the maximum of 9 for 2 squares summing up to 3 should only be 1, because the only way I can make 2 squares sum up to 3 is just 1 plus 2. That's it. What does the static assert want as the second thing? Come on. Expect the diagnostic message, right. The only option for 2 squares to sum up to 3 is 1 plus 2. Okay. This should work. And I think it does. Okay. Let's just quickly double check. So see out number of sets 4 to 3 is number of sets 9 to 3. Okay, let's see if this works. Indeed. Okay. So then well, let's just try other stuff. So, what would be a good thing to test? So 1, 2, 5, that's 8. And I can make it in other way, so that would be a 2, 3. Oh, can I actually? This is already 5. I can do 1, 3, 4. I think that's actually it. Can I make 8 with 3 numbers in a different way? I don't think I can. Because again, like if I make the first one 2, then it needs to be 2, 3, and I'm done because this is sums up to 5. This one would have to be 3, which is wrong. Okay, so let's just double check. So if I do static assert 9, 3 numbers summing up to 8. Okay. One thing that kind of just worked randomly, but I didn't write the entire condition. So this should be 2. The options for 3 squares to sum up to 8 are 1, 2, 5 and 1, 3, 4. Okay, let's see if that works. Oh, and I forgot to actually do the printout. For 3 and 8. 3 and 8. Yes. Oh, and I'm forgetting to put in end lines. Right, cool. So we have a function that just returns the number of unique sets for a particular combination of the number of squares and the sum. So that's good. Now and it works at compile time, which is the important part. I need a function to generate the sets, but well, that I'm already kind of doing it here. The only thing is, in this if, instead of increasing result, I would actually put it into some data storage somewhere. Which gets us back to the idea of how the heck do we store this and where do we store this. So right, I was saying that if I just make this a grid, so that would be, it would be std array. Right, I need, okay, let's go to CPP reference. CPP reference. Std array, right. Okay. So this will depend on the size of the puzzle, because this will clearly have different number of elements based on if we are looking on a 9x9 Sudoku or if we are looking at like a bigger puzzle. Right. So what would be the best way to wrap this? And there definitely needs to be a runtime element to this, which is actually, okay, right. So we can have like bunch of these pre-computed grid for each size. but we need to select the correct one at runtime, because if the solver is just supporting like different sized puzzles, like if it gets on, you know, reading the puzzle from a file, if it sees, oh, this is 16 by 16, well, then it needs to actually grab the correct grid, but that's based on dynamic data, so that needs to be at runtime, not at compile time. Okay, so that's one layer I will not worry about right now. Okay. So for specific size, I know exactly how big the grid should be, right? Like the minimum sum is always 3, because 1 plus 2 just that's a constant that remains the same no matter what's the size of the puzzle. But the maximum sum changes, and the maximum sum is always the size plus size minus 1. So for 9 by 9 it's 9 plus 8, for 16 by 16 is 16 plus 15, and so on, right? Yeah, for this would be for 2 squares obviously, right? And then if I have more squares it just goes on. So I know that for a 9 by 9 the absolute maximum sum, as in the sum in a row or a column, will be 45. And actually for this thing there should be a formula. So this is I think this should be like n times n minus 1 divided by 2 or something like that. No, formula for sum 1 to n. Yes, okay. So is this actually, so this would be 9 times 8, which is 72, divided by 2 is, that's 37, what? Not minus, plus. Okay. Right. 9 times 10 is 90. Divided by 2 is 45. Okay. Now that makes sense. Okay. So the maximum sum. Okay. The maximum sum I can also compute out of the size of the puzzle. Okay. So then, what I kind of want to have, I guess, is a template okay. So here we would have an array. So std array, let's just make it a struct for now and then I will change it later. So it would be std array of std array So the inner one is the number of squares, and I know that the number of squares is 2 to max, which means that this is just like max minus 1. And the internal one is the sums. So this would be... So here I actually want to have the offset and length. Right, so this would be unsigned, unsigned. Okay, I need to make some type defs because this is getting crazy. So type def std per unsigned, unsigned. Let's call this index. And this will be max times max plus 1 divided by 2. Okay. Wait a second. Did I do it the other way around? Oh. No, this is what they're complaining about. Unexpected type name index, expected expression. Oh, am I just not including std array? Is that the problem? It might be that. Yes, okay, so it was just missing include. Right, and this is the offsets, and then next to that I will just have the std array bit set sets, right? But here, okay, so for now let's just put the 1 here, but I need to figure out this number as well. And this is obviously Sudoku bit set, right? Okay. So some of these offsets will be not initialized because clearly, like I cannot reach all the sums with all the combinations of squares. So with 2 squares I cannot go up to 45, obviously. Which is fine. Basically, as long as I have some checks around that make sure I don't do stupid stuff, this is not really a problem. Okay. So how do I get this number? I have this thing, which is the number of sets for number of squares and sum. Can I just do a const expert total, like total number of sets? I mean, this will be incredibly inefficient. But I mean, this should be just calculated once. So I keep misspelling unsigned all the time. Right, so basically just loop Oh, with this I could already set the offsets actually. Okay, I'm already seeing some potential optimizations I could do. Right, so the first loop needs to go through the different number of squares. So actually, let's just do 2 until max. And then the internal loop will just go all the possible sums, which starts at 3 and then goes up to max times max plus 1 divided by 2. Okay. And then what we do is call this thing. So result plus equals number of sets. Okay, that's actually a thing I need to test. So number of sets, number of squares is I, and sum is j. Okay, but one thing as I said, I haven't tested is actually what happens if I call this with a nonsensical thing, because that will definitely be happening here. Like I will be asking, oh, give me the number of sets that sum up to 45 but have only 2 squares in them. Like that's part of the inner loop. Like this just goes over all the possible sums always, no matter what's the I, basically, right? And I could make this better by basically taking them. Yeah, I kind of know the upper bound of what I can sum up. Like basically std min of max times I. So take the minimum of the maximum sum and just take it the like maximum value, putting it in every square, which is of course nonsensical, but that's kind of the upper bound for what I can get, you know, within these number of squares. So for 2 squares this would be the take a minimum out of 45 and 18. So this would only go up to 18, which is already much better than, you know, just looping out to 45. Okay. So, but what happens if over here I do number of sets for 9, 2 squares, but the sum I want is actually 18, which is impossible. That would be 2 9s. So this should be a 0. With 2 numbers sum up to 18. Okay. So let's just see if this still works. And it does. Okay, so this indeed works correctly. Looping over the stuff. So then, okay, let's just see what happens if I do this. Because actually, honestly, I actually don't know what's the number. If I just put a 9 here, I honestly don't know. So let's just see it. The total number of sets for a 9 by 9 Sudoku. Okay. $502. Okay. And for 16 by 16? Oh, I didn't change the text. Okay. Okay, I kind of feel like that was calculated at runtime. Because the compilation, yeah, okay, like it's, I can clearly see there's like something is computing over here. Like there was a pause after the 9x9 print. So this thing is actually running runtime. I can actually force it const eval. So now this thing will run at compile time always. So let's see. Okay, now the compile time is chugging. Okay. Operation count exceeds the limit. Right, okay, so this is, it's complaining that this is just too expensive for const explorer. Which is, I mean, that's a valid complaint for sure. So damn it, actually both of these have a problem running at const explorer. And that's because like this thing is just too expensive by itself, the number of sets. I mean, is there an easier way to make this work? I mean, there's, okay, so I really would prefer to avoid that, but what I can always do, I can literally generate, like have a simple program that generates a C++ header, and all that the program would do would just, you know, basically at runtime do this magic, but like essentially that program would be just run once, because like the moment I generate all the tables, I don't have to touch them anymore at all. So that would be a backup solution. But I kind of feel like this has to be possible somehow. The trouble I'm running into is that over here I need to know the total number of the sets. And okay, I mean inherently also this thing, like this is kind of equivalent to generating all the possible like basically the content of this, right? As a side effect, it's calculating the size, but I mean what it's actually doing, it's actually going through all the bit sets that would be in this array. But this is already complaining that this is too many operations, so so maybe having just an external program that generates a C++ header wouldn't be the worst idea. I mean, it's kind of me admitting a failure to a degree. Because one of the reasons why I was making these like iterators and const expr things was to actually be able to do this. It's compile time, but yeah, I mean there's a lot. It's Like, this is definitely correct. Like, there's a lot of operations happening here. But, like, I'm asking the compiler to do a lot of things. And the tricky part is I actually really need this to be just compiled and data structures, because if they are not, like, all the killer Sudoku support will be way too slow. Like, I don't think I can make it fast enough without this. Okay, I will take a 5-minute break and think about it during the break. I mean, one thing I can always do is there's it's even telling me about it, there's a flag. So I could play with this flag and increase it. Actually, it's only complaining on the 16 by 16. It's not really complaining on the 9 by 9, even though it's underlying this one as well. Okay, let's just see if I just comment this out. Okay, so it does actually work for the 9 by 9 case. It's just the 16 by 16 is already too much. And yes, okay, I mean, it makes sense. It's a big jump. But is this actually correct? 502. It actually sounds a little bit too high. Maybe. Okay, let's see. So, killer Sudoku sums. Yeah, I mean, so this is definitely not 512. Like, these are all the possible. Okay, let's make it bigger. Right? So these are all the possible things. Pretty sure this is not 512 elements. Like, the longest thing here is 1, 2, 3, 4, 5, 6, 7 times, let's say 2, 4, 6, 8, 10-ish, 12-ish. So 7, but that's 80, 100, well, it's not 500, but it could be like a 300, 400. But maybe I do have a bug in the code. Okay, it's still the same stuff. So if I go to killer Sudoku, right? So if you have a cage that, you know, has 3 squares and some 9. So these 3 things are the only 3 possible combination of numbers that can be here. So it's either 1, 2, 6, 1, 3, 5, or 2, 3, 4, because those are the only 3 combination of numbers that end up being some 9, right? And what you can then do, you can basically just create, you know, this list of things, like, you know, 4 squares, sum 21, these are all the possible combinations. So what I'm actually trying to do is, like, during compilation time, generate all this Because, I mean, again, this is just for a 9x9 Sudoku, right? And I could just, you know, literally just take this and put it into my code, like manually. But I kind of want to have a way to just... Again, I'm trying to make the code as generic as possible. So if I would just, like, you know, copy paste this data, then, I mean, yes, I have the solutions for 9x9, but it's not generic. But the thing I'm looking at right now is that... where's my code? Right. So my code is saying that for 9x9 Sudoku, there's 502 like total elements in like all of these together. But the thing is, this doesn't look to me like 512. I mean, it could be that I'm bad at estimating stuff, but like, okay, so this is like 2, 4, 6, 8. Well, actually, maybe it is 512. Because there's like deceptively many here. Like, it just looks short because there's only a few numbers in there. Nah, like what made me think that was, I think I just got bamboozled by the fact that like some of these look deceptively short, but it's actually quite a lot of elements. They just look short because they are short numbers. Okay, so I mean this could be 412 actually, but okay, I will take the 5-minute break and then just like test a couple of like random combinations, because I can just, you know, reference this table and double check it. You should learn how to play Sudoku. Sudoku is great, especially like the variants, like the killer Sudoku is just great. It's a lot of fun. Okay, 5-minute break. See you then. Okay, and I'm back. So, I have made a decision. So, considering it works for 9x9 as of right now, I will just not worry about it. Which is like kind of delaying the inevitable to a later date, but I mean it works now, so whatever. But I want to test basically that things are working correctly before I wrap it up. So let's just test the 4 squares with, like, you know, 19, 20 and 21. So this should be, for 20 it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. Okay. So let's see. So 4 squares summing up to 20. What did I say this was the number? Damn it. 12? 2, 4, 6, 8, 10, 12, yes. And I mean, okay, I will not print out the 12 different... Oh, actually I can just copy it from here. So I guess I can do that. Number of sets for 420. So 420, right. So this should all work. Let's see. Yep. Okay. So now I think everything is fine. So then this thing should just go over here. Okay. Yep. And now I just need to fill it. So that will be a very similar code actually to what I already have. So these are so far just counting the number of elements. Now they'll be taking the sets and filling it in. And also the offsets, right? Okay, so it will be similar, right? So first of all, let's just have this. Fill sets. And this will take the offsets, and let's just make it auto, and the sets. And actually this will just be a void function because it doesn't really need to return anything. But it needs to take references to both of these. I mean, alternatively this could be like a generator that just returns, yeah. But in this case, like, considering I need to set this up anyway with the constant sizes, yeah. Okay. So we'll definitely have this loop. Yeah, basically something like this still. So we go over the different number of possible elements. Okay, so we still need the max actually. Okay. Now I just need to be very careful. So I need to remember my current offset. So we start at 0. and the length. Okay, so that would be a thing that will need to come from the second function. Okay. So here I want to do a fill set. Still needs to know the maximum. It needs to know the number of squares and the sum for sure. That's still the case. It will get the sets as parameter and it will fill it in. But then I want it to return the actual length that it did fill in. And after that happens, I want to do offsets I j equals std. No. Yes, std. Well, std pair, which is the index thing over here. But sure. Well, actually, make pair of the offset and length. So this fills in the data, this stores the offset. Okay. Right, okay, so actually num squares is I in this case, and the sum is j. And then the fill set function will be similar to the one that actually counts the sets, except over here, when the sum is actually correct, I will not be just increasing the result. Okay, so I actually don't need the, well, I don't need the result, but it will have a different meaning. Okay, and this needs to have a slightly different interface because it also needs to take the sets. Okay. One more thing I need to pass in. I need to pass in the offset so far. Right. Which is not a problem because I have it here. So when the sum is correct, I want to go to sets offset and set it to S, which is the set. Yes, but I also want to increase the offset then, right? And I want to increase the result. Actually, let's make it slightly cleaner. So we are not overwriting our input parameter. So yes, we start at the index of offset and then keep increasing it with the result, and then the result at the end has the number of things we have written, and the index just keeps increasing monotonically. That's fine. And then over here, actually what we need to do is offset plus equals len. So again, this returns the number of elements we have written. We need to move the offset by that much. So I think that actually should work. So if I just do this fill sets 9 and then offsets are offsets and sets. Well, okay, actually let's do it. Fill sets max. I don't need these things anymore, but let's not delete them, let's just comment them out. And what I want is to have this thing with the size 9 over here. Okay, let's see if this actually compiles. Okay, it doesn't like something. Oh, because I didn't rename this one, so this should be fill set. Okay. This is not a constant expression. Right, because I didn't make this constant expression. Okay, let's try again. No, it's still complaining that this isn't constant expression. Damn it. Okay, actually, this should just be static. Right. Okay, modification is not damn it. I mean, the compare is not wrong. I wonder, could I rewrite this in a way? So okay, like yeah, I'm not surprised that this didn't work, because yeah, I'm kind of abusing the const evil here. But actually, what I could have done is, if I have const expr, this is a little bit awkward, but okay, let's just bring it back. So if I just have a templated function, is generate offsets, right? Well, actually, I don't need this even. And then I can literally just like return this thing. Basically with exactly the same code, except the result. So okay, so this will be max. Okay, I need to change these things around a little bit. So actually the length will be number of sets now, and that I can definitely do at compile time. So number of sets for max ij, and then oh, not here, editing the wrong place, over here, yeah. Ah, damn it. Number of sets for max ij. So now I have the length, I have the offset, so then just result ij is this thing, and then I just return result. Then I think what I can do over here is offsets, generate offsets, 9, well not 9, max, obviously, right, like this. Offsets does not name a non-static. Oh, but now this thing is static. Well, okay, so then actually this should be okay now, because it's a static member, non-const static. Wait, it definitely should be const. Const expr must be initialized by the constant expression. Oh, and this hit the limit again. Oh, damn it. Well, that's annoying. Okay, so this is actually nonsense. Oh, okay, this. Oh, okay, that is nonsense. Oh, wait a second. Is it actually okay now? Or is it just because I'm not touching it, then it's pretending to be fine? So let's just do cout some grid offsets, some grid for the size 9 offsets. Let's do, well, 2. Well, I'm counting from okay, actually this is wrong. So this should be I minus 2 and j minus 3. Okay. So offsets at 0 with some 3, which should be 0. Okay. So this should be So it's first and then second, I guess. Okay, because this is a pair. Okay, cool. Second, right. Okay, not quite sure what this is complaining about. Context, right. I mean, this literally should just be context per needed for in-class initialization of a static data member. But the thing is, like, this should be, I mean, I just made it a const eval, so this interesting. I would think that this is okay for a const eval function. I mean, I have one std error, like one thing that I return in one place. I just fill it in. So, I mean, this should all be okay. Context per needed. Oh wait, is it const expr over here actually? Is that what was the non-static declared const expr? Okay. Ah, good. Okay, now we are cool. Right, and this actually 0, 1 actually makes sense. Okay. Right. Okay, so this actually works perfect. So that means I can do the same thing for the sets. Okay, let's just get this. Yeah, so this would be an std array. Basically this actually. Oh, what is the 9 doing here? This shouldn't be 9, this should be max. Okay. So we have the result. And now the result. Okay, now this needs to be a little bit more fancy. Because over here, I basically need to do this thing, right? Okay. So max number of squares is I. Sum is j. So okay, so if the sum is this, then what I want to do is result at offset is s, right? Then I want to increase offset and over. That's actually it, right? Because the offset and the length I have already set over here, So really I just need to fill in the data. Okay. So this would be generate sets. Okay. Oh, and this needs to change a bit, like that. Yep. So sets equals generate sets. Max. Okay, and this needs also to be a const expr. So let's see if things explode now. They shouldn't. They don't, which is good. So okay, so now literally I should be able to do a loop. So basically an inverse loop of the one I have inside of the functions. So let's do unsigned I. So let's go over the yeah, basically this loop. Okay. Sure, 45. And let's just print out this table, basically, that's my idea now. Right. Okay, no, I know how to do it. So I want to grab the length so the length is sum read 9 offsets at I minus 2 j minus 3 dot second. So that's the length. So then what I want to do is okay, less than length 3 plus plus. Yeah, and if the length is 0, this will do nothing, which is exactly what I want happening. But actually, let's make it more explicit. So if length is 0, then just continue. It basically means we don't have a record for this number of squares summing up to this number. But if we do, then what I want to do is first of all print out like a simple header, which would be the sum. And actually I want to play a bit with the alignment. So IO manip. Oops, no. IO manip. Right. Set W is to width. Right, so let's do set width to like 5. Let's print out the sum, which is j, then a colon, and then after that cout set width. Yeah, okay, so set width 10. I'm missing the include. Yeah, I manipulate the header. Okay. So now it should pick up. Come on, yes, okay. So sum create 9. Is it data or what was it? Sets? Yeah, sets. I call it sets. Right. So sets at offset, okay, unsigned off will be first. Offset plus k dot the debug string was the I had this method that just gives like a nicely formatted output somewhere. I think it was debug string, right. Oh, actually I need to give it more space than 9 or 10 or whatever I put in. So this will be 9 plus 2, so minimum it's 11. So let's, well actually I don't need to do this at all, I just realized. So let's just do this and then a space after that. Okay. No member named set. Okay. Not quite sure what's happening there. Okay. So we loop over all the sums. Okay. Once I printed all of them, I definitely want to do a new line over here. And for each of these, I kind of want to print out a new header. Sets of squares, sets of, okay. Squares, okay. Something like this. So we print out the header, then we just loop over the stuff, and let's see. I mean, this looks like it's working. Okay, this is great. So now I just need to do one more sanity check. So this is kind of showing that it works at runtime. But basically, let's just pick. I mean, for example, this thing, right? So this is 3 squares summing up to 18. Okay, let's put it down again. So if I do a static assert, static assert on sum grid 9 sets. So the offset will be, okay, damn it, where was that? It was 3 squares summing up to 18, I said. Okay, so 3 squares summing up to 18. So this will be 1 summing up to 18, so this will be 15. So this is the offset, and I don't care about the length, but this dot is bit set 5 should be true. The same for bit 6 and 7. Okay, let's see. I mean, yep, that seems to be working fine. Even though my IDE seems to be a bit confused. Yeah, not quite sure what is happening here. I think like the... Yeah, I kind of have the feeling that like since the ID is running the thing that figures out the code completion, that one is actually running into errors. But I mean, this seems all to be working, so cool. So we have this compile time big table of things, which is exactly what we wanted. Okay, so now I can start playing with this. But I should just wrap this up somewhere and right. I mean, okay, let's just get rid of this index because this isn't really improving the readability at all. Okay. Yeah. No, I think, okay, I think this is fine as this, okay. Let's just quickly double check. Okay. So, let's, how will I do this? Let's make a new directory over here, which will be, I'll just call it killer. And right, so this will be, don't add this into anything. Killer sums, right. Let's just copy this quickly. So this is template, so it needs to be in the header. I need to include array and right, I need to include from core bit set. Okay. And yes, I need this function, so I need the total number of sets. Total number of sets, where is it? Here. Which needs the number of sets, yes. Okay. Just make it inline so it doesn't explode. Actually, I wonder. Can I have this inside of the .cpp? That's one thing I want to try later, but I'm kind of thinking probably not, but yeah. Yeah, and these are actually templated functions, so they actually need to be in the header as well. Okay. So really I can only move these to the total number of sets and this one. Oh right, make pair, so this should be std make pair first of all. Yeah, okay. So this should all be fine now, I think. Oh yeah, and this still should be in line. I mean, technically this actually should be in, because really the only thing that needs them, so this should just be in an anonymous namespace. Because really the only thing that needs to access these functions is actually the sum grid. Okay. And this, let's just do a namespace Sudoku and namespace. I wonder, does it make sense to have a separate namespace for killer Sudoku? Probably not. Okay, let's do that. And why is this again? Something happened again and my format is broken again. Like, this shouldn't be indented. Like, why is this indented? That's wrong. Very, very strange. Okay, so we have our static grid of things. Which will only work for 9x9 Sudoku for now, because we run into const expr limits. But to be fair, all I really need to do then is just to increase the limit. So in a sense that's kind of okay. Like, it's not a massive deal that this doesn't work for bigger Sudokus right now. And actually looking at the time, I'm considering this is a natural good stopping place, so let's just take a break. I will definitely stream for at least 1 hour more, probably 2 more hours, well, we will see. But yeah, I need a short break. So see you in 5 minutes-ish. Okay, and I'm back again. So we have this thing, which is great. So the context per experiment can go away at this point. And also from here. And now the thing is, so what I can create is a killer block class. Killer block. Right. Okay. So, okay. I'm trying to think which way to do this. I'm kind of thinking it should just have the same interface as the unique block, honestly. Because a killer block is still a unique block. The big difference is the extra logic that's there. So I'm actually thinking about this having a unique block inside of it. And this should all be in the Sudoku namespace. Right. Yeah, okay, I need to figure out what the hell is wrong with my code indentation again. Right, killer block, vector, that's fine. Input vector I need for sure. Right, I also need the input bit set, core bit set. Okay. Yeah, okay, I really have no idea what the hell is wrong with the indentation, like it's going absolutely mental. So block, just pass in these parameters. Yep. Is complete block, so return. Well, for killer blocks this would kind of not really make sense, but I mean, we will have kind of fake blocks, fake killer blocks that I will need to create, because one of the solving techniques is kind of finding remainders, and for that I kind of need to create the full blocks that represent each row, column, 3x3 square, and so on. So actually this will be pretty important. So block is complete block, but yeah, like basically all of these methods will just be passed in to the actual block, and there will just be extra methods, number, positions, number, extra methods that will just add the functionality of the killer block into it. Right. Okay. Oh, and I also definitely need to include the actual unique block. So this is from core unique block .h, and yep, that should be it. So now for the actual unique behavior. So what I will need here is an std bit. Oh, how will I do this? Yeah, I think I cannot use a bit set because a bit set. Yeah, so this is a static thing, cost expert. It's templated by the size. But the size for the kill blocks will be a dynamic thing, right? So actually what I want is a vector of booleans, I think, which is just a special special instance of vector. Yeah. Yeah, I think I want the vector of booleans. Okay. So then I will have a vector bool over here. So this will be the possible sums. So this will store which sums. It shouldn't be possible sums. It should be possible sets, right? So which sets summing up to a particular number are still possible. And this is referring to the killer sums that we made before. So basically from the sum grid, like, okay, let's look at the output, right? Like, let's say this is a kill block of 7 squares, right? And it should be sum 35. So basically this will be represented by 1 bit, this will be represented by 1 bit, or I mean 1 element in the vector, and so will this and this. And as long as the elements are true, then, you know, this is a possible set, this is a possible set, this is a possible set, and this is a possible set. But as we like figure out, for example, oh, you know, this like block doesn't have a 2, then that already eliminates this and this one, and the only possibility remaining is actually this one. So we know exactly what is the set of numbers in this block. So that's kind of the idea. Like with this we can then just go and figure out, oh, okay, like now we know that this cannot possibly have this number anymore, and it actually works both ways. Like we know that if, you know, if you union particular sets from here and the union is missing a particular number, well then obviously the number cannot be in this block. So it's kind of a propagation technique that works either way. But yeah, this needs to be vector because this is based on the size, which is actually a thing that comes through the constructor, so it's not a compile time information. Okay, and then the actual two things that are described, well, the one thing we already have is the size, because that's inherent in the unique block, but the thing we are missing is the actual sum. So this will just be unsigned sum. And that I need to get through the constructor. Right. So So sum is sum. Okay, now I will definitely need, oh, and I also need to initialize the possible sets. So the possible sets, okay, so this I want to initialize with there should be, right, this one. So the number of elements is lm.size, and oh, actually not lm.size. Shoot, right, okay. This is actually information we need to get out of the killer sums. Okay, so first of all, this needs to be included over here. So include killer sums. So the number of possible sets is actually the killer, oh, how did I call it? Sum grid, right. So sum grid with the size of, okay, I already need a helper method or function here, because obviously I cannot do this because this is a local variable and this needs to be compiled and constant. So I kind of need to make a little bit of a workaround. Basically over here, let's just make a simple function. Damn it, okay. Right, let's just make it unsigned get. Oh, actually, I also have the number of sets. Oh, I can actually use this one. Okay. And then I don't have to. Damn it, but I will need to work around the fact that this is a template somehow. Anyway. Because I will need to access it, and again, my current max is a variable. So I kind of need to hide the template and just work with the instantiation of it. I can basically make like accessor methods. Yeah, okay, well, let's do that. So I can do basically this, right? I can do. Okay, I need to put it after the sum grid definition, but basically I can have a unsigned get number of sets for unsigned max, and again keep misspelling unsigned. Unsigned max, the number of squares, and the sum. But then with the max, what I will do is if max equals 9, then then I do return some grid 9, and this is the way how I'll kind of hide the template basically. So the number of sets is from here, num squares minus 2 and sum minus 3, right? Is that correct? Yes. And the number of sets is actually the dot second, right? Yeah, it's the length. Okay. I should really just document this before I forget again. So this is offset length, so num squares sum into offset and length, right? Because I will just keep forgetting that this is the case, and otherwise we just always return 0. This actually can be const expr. Not that I will be actually using it in a const expr context, but it could be, so why the hell not? Right, and I will definitely need more of these methods, functions, but yeah, we kind of need to hide the template by doing this kind of interaction. Right, so over here, get number of sets, and now I can actually do max lm.size and sum. And these I just want to set them all to true, so at the beginning all the possible combinations are possible, obviously, and then we will be slowly eliminating them. What's the problem here? Implicit conversion loses precision, which is fine, so let's do let's just explicitly cast this. Okay, that's fine. Yeah, and sorry, I'm realizing that my overlays are in the way. Actually, can I move this to the other side? Maybe I can. Okay, well, let's just move all this stuff so it's kind of on the other side. I think this will be better. And yeah, this doesn't need to be that big. Okay, yeah, that looks much better. Should have done that a long time ago. Okay. So we have the... Oh, we definitely need an accessor for the sum. Sure, this can be const expr, doesn't really matter that much. Okay. So now what I want to do with the possible sets is basically I want to have return the union of all the still possible sets for this block. So this will return the union of all the sets that are still possible in the skill block. So I mean, as if I just jump to the example, right? Like, let's take something that actually, okay, so this one. So this would return 5, 6, 8, 9 as the union, because those are all the possible number across all the possible sets. But clearly, like, I cannot have a 1, 2, 3, 4 in this block, or 7. So that's what the union will do. So no discard. So not be a constants per thing, because this works with the boolean, the vector of booleans. So I cannot really make it const expr. But this will be returning a bit set. But it will be const. Okay, union, and it should be no except, because I should not be in a situation where I'm going, like, I can technically have an exception because I will be accessing a vector, but there shouldn't be a situation where I would be accessing outside of the bounds of the vector, because of the way I actually initialize it here. So I should always be accessing like within the bounds of the vector. There should be no except. There shouldn't be a situation where there is actually an exception thrown. Right. So it said result, return result. And yeah, so yes, I just want to loop over this. Size. Okay. And now I need another helper function that will actually grab me the correct bit set out of the big table of sums. But basically what I want to do with that is just result or equals with the something that I will get here, alright? So where is it? Here is this. Okay. So let's do const expr bit set get set unsigned max, unsigned num squares, unsigned sum, and then unsigned offset. Okay, so a little bit complicated, but yeah. Again, we just hide the template by doing this magic, and otherwise we just return bit set empty. There's a, why is this not code completing? Come on, wake up. Okay. Empty, right. Bit max actually, right. So first of all I want to get the offset right from here. So this time this will be actually the dot first, because that's the offset. The second one is length. Or this will not be the return actually. So unsigned off is this, and then what I actually want to return is return set with offset plus is there, let's call it base offset. Okay, base offset plus offset. Okay. Not superbly readable, but I guess it will work. Sets. Oh, this is of course some grid sets like this. Okay. Then over here, what I want to do is get set with right. So max is max is max. So that will be block dot max. Then okay, what were the parameters again? Num squares. So num squares is block dot size. Then oh, come on. Then the sum. So that's just sum, and then the offset is I. Okay. And I should write a test for this because this is already pretty complicated stuff. So let's do that. Right. Oh. Having this on this side is a bit unusual. I will need to get used to that. So let's just make a completely new test for killer Sudokus. So let's just call it killer test. Yeah, okay, don't really want to add it anywhere yet because this will need to go here. So add executable killer tests. This should just be killer test cpp, and then I want to link libraries. So what I want to link it against is let's see, the killer tests. So definitely core. Oh, but I don't have right, I need to add actually CMake files for this. Okay, that's a thing I don't have yet. Right, so CMake lists over here. Sure. So this will be actually similar to this. Let's just do that, and let's just call it killer. Okay, yeah. At library. Right. Killer, and this will be just killer block cpp. I don't really have to specify the headers, but I will do that because that's just what I do. And over here, actually, I need to specify this as a subdirectory. Not subdirectory killer. Okay, oops, 2 else. So yeah, that should all be working fine. And then over here, I can just say also link it against killer. And that's, I think, oh, thanks, man. Welcome to the stream. So, project options, project warnings. So, like, this is already really grinding my gears because I'm actually used to Bazel because I was working at Google and got used to like very modular style of building things. So this is already kind of not enough to me. I would really like to like basically have a module per, you know, unit and then just like explicitly specify everything everywhere. That's one thing that like I mean I do get it like why it's done this way, because like CMake is not really a build system, it's a like build file generator. But yeah, I'm really wondering what they will do for modules, because right now CMake isn't very like modular as it is. So I kind of wonder what will happen there. Right. Discover tests in killer tests. Did that work? Killer. Okay, I have killer tests now. Okay, so this if I just built it. Okay, cool. It seems to be working. It's compiling for forever because I'm doing a lot of compile time magic. But otherwise it's working. Cool. Of course I don't have any tests yet, so nothing is really happening. But let's just copy a test from here. As a quick template. This is the end of the namespace, and I need to include. Oh, I also need to include. Where the heck is it again? Oh, it's just right. So I need to have the catch. Right. Okay. Include. So out and then right, source killer killer block. Okay. Okay, what the heck happened here again? Why is this indented? I shouldn't be. Okay. So this test is killer block basic test. Let's get rid of this. So right, okay. I think I will need to copy some tests from the unique block test. Right, because this had the like helper stuff. Okay. Let's just copy this for now. I will need to figure out how to. Oops. Okay, how to actually have this as a library for my tests. Right, so simple block. Was this actually used? Right, okay. And then I just initialize it with that. Okay, that works. So simple block. Let's call it data. Initialize it with size 9, next 9. And then I can create the kill block with the data dot block data and where were the other parameters? Oh, come on. Why is it not cooperating again? Oh, the maximum and the sum, right. So the maximum will be 9u and the sum, let's just say oh, actually, okay, let's just create the kilo block of 3 elements because that actually makes more sense, right? So let's just have 3 elements. Maximum is still 9, and let's say the sum is 15. I'm just making these numbers up, it doesn't really matter, but okay. Actually, I should just pick, well, I can do basically this. So this is 2 squares summing up to 14. Okay, I'm trying to find something. Okay, this would be a nice test case. So it's okay, let's write this down. So 6 sum 6 3 squares should be 1 2 3. Sum 14 2 squares, the union should be 5 6 8 9. Anything else that's kind of interesting? Okay, this is not bad. So this is a 9, so sum 9 3 squares, and the union is 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, I think that's good enough testing cases for now. Right. So I want to check how do I do this? Right. Well, okay, let's then call this test actually union, because that's what I'm doing here. I'm just testing the union method. So let's create a 2 and a 3. Oops. What am I pressing? Right. 3, okay. Oh, and call it 3. Okay. So let's call this one. So this will be the 2 square to the block data, and the sum I want to be 14. So then when I get bit set q1 k1 dot union, then I expect that check q1 count set is 4, and I also want to check the specific bits. So is bit set 5, is bit set 6, is bit set not 7 8 and 9. Then the same idea with another kilo block. So the K2, so this will be the free block thing, free square block, I mean. So this one will sum up to 6. Okay, so this union, check that the count set is free, and then check if the bits are correct. So 2, 2, 2. So is bit set 1, 2, 3. This is fine. This is fine. And then the last one. Okay, call it K3 and U3. So the sum will be 9. And I expect 6 bits to be set, and the bits I expect to be set, well, this one might be easier to just check in the inverse, so let's just do not is bit set 7, 8 and 9. Okay. So that should all be fine. Cool. So the union is working fine. And by definition that, well, not by definition, by, what do you call it? By transitivity? Yes, by transitivity, also the like sums thing that I built is actually working fine. Okay, so this is one thing I wanted, is the union. I need some ways to manipulate the vector, basically. So how would I do this? So this kind of is starting to head into the algorithms for solving, which is a kind of another topic entirely. But at minimum I will need like way to say that this block like either cannot contain or must contain a specific sets of numbers or one number, right? So it's kind of like a prune, but working on the sets. Okay. Something like like I almost want a method that will look at the underlying squares and remove sums that are not possible. Yeah, I mean that's pretty much it. So, but I don't quite know what to call it. It's like remove impossible sums or something like that. Given the state of the squares contained within the block. And I mean, okay, so now the problem is there is a possibility to have a lot of logic here that I don't necessarily want to have right now. Because there are like weird corner cases, right? Like I can do like simple stuff, like okay, like if there's a 1 here, right? Well then clearly I can remove the 1, 2, 6 and 1, 3, 5 because those, you know, cannot be here. But there are like weird situations. Can I actually make that somehow work? So like okay, okay, that doesn't really work. What would that be? It's like yeah, 6, 5. Okay. Oh no, that's still, damn it. Yeah, I cannot even replicate the situation that I'm thinking about right now. But there's definitely situations where it's not so obvious. Like okay, so if I make a 5, 6 here, right? Like what will happen is 5, 6 cannot be in this block, so remove these two again. But I mean that happens very naturally, so it would basically remove the 5, 6 from these squares as possibilities, and then basically that means okay, like these two sets become impossible. Yeah, it's basically what I'm thinking about is kind of the difference between just making a union of these squares versus actually thinking about, right, okay, so if I have okay, so if I had this kind of situation, so if the 5, 6 was actually here, so then 5, 6 cannot be here, but this square still has, oh, that's a bad example again. Okay, let's do 2, 3, right, okay. So now, like if I do a union of these squares, like the 2, 3 cannot be here, which means that this square needs to be 2 or 3, because basically this, like all of these need to have a 2 or a 3. But it also means that this 2, 3, 4 is impossible, because I cannot stick both the 2 and the 3 into this square. So this is where kind of the difference of just making a union of squares versus like actually thinking about the cardinality of things comes in. Would that actually be it? Just like looking at the cardinality. No, even looking at the cardinality doesn't help. The problem with this situation is like I really need... Damn it, how would I even check for this? Like this is not easy. What could I do? It's an interesting case. How would I check that this is not possible? Like, it's almost I need to actually look at like the permutation, like manually check if I can distribute the numbers into the squares. Yeah, I actually, I must admit, I actually don't know how I would. Like, I know how would I do it like brute force way, but I cannot really think about like an nice and simple way to check that the 2, 3, 4 is not possible here. Huh. Okay, so I mean, let's just ignore that for now then, and let's just do let's just do the simple union, right? So let's go over the squares and union. Okay, so this actually shouldn't be called union. So this should be called union sum sets, which is a horrible name, but union was very like confusing. It definitely shouldn't just be called union. And let's just change it in the test. Right. So what can I? So here I really just want to union the numbers and then check that against the sums. So basically, if I have a situation that the union of my squares doesn't contain the set from the sum, then I should just remove it. Oh, I just realized how I could detect this. So if I look at these sets, yeah, no, that still doesn't work. Damn it. Ah. Never mind. Okay. I will just write this note down. Simple union over the contained squares. Check against each sum set. Remove those that don't match up. Okay. Right. Looking at the time, I think I need a short break again. So yeah, I will be back in 5 minutes. See you then. Okay, and I'm back. So, I think I will just stream for a bit more and then call it a day for today. Right, so this thing, actually probably not this card, so this will be, let's just call it prune some sets. So it cannot be, yeah, so it cannot be const, but it should be no except. Okay, so as I said, let's just make a simple union over all the squares. Actually, I just remembered I should have a union. Oh yeah, I have a union here. Okay, cool. So then what I want is bit set. Obviously I cannot name it union. Let's just call it set, which is not improving situation too much, but it's good enough for now. So union, for that I will need to include the algorithms, I guess, which, okay. So this is from core Sudoku algorithms, right? So please union the squares, which is block.getSquares, and what else does it take? The bit selector. I mean, I kind of want all of them. So I guess in that case the selector will just be, where is this actually used? Find usages. Yes, because I use it with ether. Okay, now that makes sense. But here I just want to get the union, so let's just do bit set Sudoku square max, I guess, yeah, max like this. Is that it? So what this should do, so the Sudoku square should just be a bit set with all the bits set to true. So this should just union all of the squares. And then what I want to check is for unsigned possible set size I++. I just realized I'm actually missing one check over here, so I only want to actually include this in the result if possible sets I is actually still true. Yes, because the moment it gets set to false, I definitely don't want to include it over here. But yeah, I just realized that because the same idea I want to have over here. So if this is still true, then I want to check that the get set okay, so how do I it would be basically yes, so if I remove okay, it's a bit complicated, but this should work. So okay, so I take the set that represents the sum, remove all the bits that I have in the union, and oops, if I'm left with anything, that means I have in this set a number that's not represented in the squares at all. So if extra bits actually yes, this thing, this is the method that I wanted. Which way does it actually work? Because I always forget. Has additional bits. Whether this bit set contains bits not contained within the given bit set. Right, okay. So actually yes, that's exactly what I want. So if okay, still very complicated. If so dot has additional bits set. So this, what this is literally saying is, does this particular sum require numbers that I no longer have in my blocks, in my squares, right? So if that's the case, then what I want to do is possible sets I just set to false. Okay. And I guess I can flatten this out a little bit. Okay. I need to do something about the formatting because this is really horrible. But right, let's just. Oh, jeez. Right. So if this is still possible, if this particular set is still possible, and the set has requires numbers that are no longer present, then just set it to false. And that should be good. Okay. Let's test this, and actually what I want to also test is if I remove one of the possibilities that the unions still make sense. For that I will need a helper function, I guess. So something similar to the I had a function to like remove stuff somewhere. Test get block data. Where is this thing actually being? Right. So something like this, but okay. So actually I want something that will just return me the vectorial bools. So test get get some set vector out of a killer block. So this will be the s dot oh geez, what did I call it? Possible sets, right? Possible sets. Well, actually, then let's just call it test get possible sets. Okay. And this thing needs to be a friend of the killer block. Okay, friend. And at this point in my test, I can actually go and fiddle with the oh, come on. And specifically the one that was interesting, I think was the sum 6. No, not this one. This one, right? So if I remove get possible sets. So let's get them out of the K3 and let's just set the third one to false. I'm not quite sure if, well, actually, where's the output? I did print this thing out at some point. Unfortunately, in the meantime, I just deleted everything again because I'm so proactive. Why did I do that? Okay, anyway. Now, if I do this again, it should definitely be different. That's for sure. Now, the only question is in which way exactly. Oh no, am I looking at the wrong thing? Oh no, I'm looking at the correct thing. This shouldn't have 7, 8, 9. Okay, so that shouldn't actually change. But actually I should lose the bit 4, so this should be only 5. So check. I mean, if this is lining up, it doesn't necessarily have to. The order of the sets could be different, but let's just test it. Okay, things are compiling. No. So bits. Okay, so I definitely have 5 bits, but the bit 4 is still there. So I have lost something else. So maybe it's a 5 or a 6. So let's try both 5 and 6. Yeah, this is the problem that I'm because I don't have the printout anymore. I don't quite know what's the order of the sets actually. Yeah, okay, so it removed this possibility actually, which is kind of weird that this is the second one, but I mean as long as it works. Yeah, and I guess we can continue, so we can now do this thing, and let's just remove the possibility number 1. And let's just redo this. And actually now we should jump to 3-bit set, because now we should have only one of these available. And the bits that should be set, well, let's just guess. So if this one was the last one, then I would guess that this one was the middle one, so the 2, 3, 4 remains. Okay, I'm quite puzzled by the ordering of things, but I mean, sure. So U3 is bit set 2, 3 and 4 should be the case. 3, 4, yep. Okay. Yeah, okay. So it's really curious ordering. I'm not quite sure how we ended up with that, but I mean, stuff is working, so can't really complain. So this is all working, so let's test the pruning thing. And I think that will be the last thing I'm doing today. Okay, so new test. So this will be a prune test. So let's just think about. Let's start with 3 blocks, because with 2 blocks it would be a bit hard to do these. Okay, so a kill block. Yep. And sure, let's keep working with this. Well, I guess I can actually. Yeah, okay, so this might actually be more interesting. So if I start with something like this 15, because that has plenty of stuff, then I can basically check like how many things got removed when I like removed the 7, for example. Okay, let's do that. So the sum is 15. So now if I go and, well, let's just, first things first, let's just check everything is okay. So I should have 1, 2, 3, 4, 5, 6, 7, 8 things in the vector. Can I actually check that? I don't think I'm actually exposing that. Max size. Yeah, that this is not really something I'm exposing to the public. Which, I mean, okay, that's not a big deal, because I have written the helper function. So I mean, yes, okay, let's just use that one. It's a bit awkward, but so let's check that the test get possible sets from this color puzzle is actually 8, right? Yes, 8. Equals 8, not column 8. Okay. Let's see if that works. Okay, it does. Cool. So now so removing 8 would remove 3 things. So let's try that. So for all the squares, actually it might be shorter just not even to do the loop. Let's just do this explicitly. So 3.data 0 dot, well, minus equals 8, 1 minus equals 8, and 2 minus equals 8. Just removing the 8 out of the 3 squares, and then let's do another check over here. And since I removed, oh, I need to do the prune first. So k1 dot prune some sets. Yep. Now it should be 5. and I have a 6F. What the heck? That's very interesting. What the heck is happening here? Ah. Oh, wait a second. Is my union not ready? Square. Ah, shoot. Yes, there is. Damn it. I haven't thought about this. Yeah, this union isn't really... I shouldn't be using this method. Basically, this is kind of built for the situations where the number of squares is actually the same as the maximum. And actually, I should just have an assert here that checks that. Damn it, I cannot even check that, I don't think. Yeah, this is let's just make a note of that. This probably shouldn't really be exposed like this, because this is really just like a helper function that isn't super universal. So let's just write it down. So built for number of squares equals max. Yeah, it's really built for the situation, just picking out the things out of there. So I mean, okay, let's just do this manually for now. Let's just loop over the squares. Okay, so let's start with an empty bit set. Empty with max being max, right? Let's loop over block get squares, right? And let's just do set or equals the square. Let's stop this, let's run this. Okay, but this is still not quite working, which is interesting. Hello, welcome to the stream. Just doing a little bit of debugging. Interesting. Why would this... I mean, this is really saying that we didn't actually remove any of these possibilities. Which is a curious thing, so let's just jump into debug mode quickly. Okay. So right. Okay, but I really want to see I want to see this thing. So new watch dot debug string. Oh geez. Oh, interesting. I actually managed to crash it. That's very interesting. How would that happen? I mean, I had initially I had 8 of the sets for sure. Why would it crash? Okay, let's try again. This is very interesting. Well, now it's crashing immediately, of course, because I still have to watch. Well, let's restart. Okay. So I assume this thing is true. It is. Okay. Then okay, let's just check that I don't have like any initialized values. So block max is 9. Sure, that makes sense. Block size should be 3. Yep, it is. Some should be. Why is this not evaluating? Okay, 15. That's correct. That was, for whatever reason, taking like a long time. Okay, I is 3, that I know, that's fine. Let's do set.debug string. Wait, what? Cannot evaluate maybe inlined? Set.debug string, like if I do it here. Okay, this is interesting. Wait, but here it works. What the heck? Okay, there's something weird going on. Okay, let's do our favorite. Where the hell is the programmer? Right, programmer calculator. And right. So this thing is 383. So 383 is. Yep, this, okay, so this makes sense. So this is like all the bits except for the 8, which is exactly how it should look like. but then somehow this thing isn't happy, which is very curious. I mean, I should be able to have a look at the killer sums directly. So basically I should be able to do new watch, so sum grid line offset at 1 and sum is 15 minus 3, so 12. Oh, I don't. Attempting to take a value not located in memory. Well, I mean, yes. Like, yes, these are constants, but you should be able to print constants. Don't be annoying. Ah, damn it. This is... Don't... Yeah, I mean... I know it's not in memory, like it's... But I mean, technically it should... Ah, damn it. Okay, if I do straight up this thing... Yeah, okay, that's the problem, like it's doing... Ah! This is so annoying. And I suspect this is why it was crashing, because... So how the heck do I debug this? Like maybe if I... Like I don't know if this will help. Probably not. Okay, if I just do this... I kind of suspect this will just get optimized out. I could like try to... Oh no, it actually didn't get optimized out. Cool. Okay. So, wait, I didn't... yeah, okay, I do still have my calculator. Actually, can I make this... Yeah, I cannot make it bigger. But 140. So... Okay, so this one has an 8, so this one should be removed, yes. So this is working correctly. So then 146 also has an 8. Okay, so that's correct. Then the last one is 161, which also has an 8, and that should be it. So why the heck is this failing? This is very puzzling. Get possible sets. K1 size. Oh jeez, why am I so stupid? Obviously the size doesn't change. Oh jeez, right. Well, what I want to do is just count the number of them that are true. Right. What's the standard function for that? It's count if, or is it just count? Count. S3 count. What do you do? Come on. Value to search for. Right. Okay. Yes. Okay. So what I want is std count. Well, okay. I need to do a bit of magic around here. So auto. Let's just take a reference to this. So v.begin, v.end, search for true. So this should be 5. And this is correct. Okay. Oh jeez. Like every time I have a brutal bug in the code, it's something absolutely stupid. Okay, so this can now go away. Cool. Okay, so this stuff is all working, which is very, very good. And I have been streaming for almost 4 hours, which kind of means that that's enough for today. So, okay. I'm not yet sure if I will stream Sudoku tomorrow, because one thing I actually wanted to have a look at is actually playing with the Twitch SDK and kind of writing my own smart bot to have some more interesting interaction in the chat. So I might do that. I will see. Like, I'm not sure yet. But anyway, I will definitely stream something tomorrow. So yeah, see you in the next stream, whatever it is. And that will be tomorrow, the same time, 2:30 p.m. Central European time. Or, you know, join me next week, next Saturday, because I stream every weekend. See you.